Are you ready to learn printed circuit board design? I've been designing PCBs for 30 years, and I'm going to share my secrets with you.
I'm Stephen Chavez. I'm with Siemens, and I'm a Senior Product Marketing Manager. So in this first best practice pillar, I'm going to cover an outline how a digitally integrated and optimized multi-domain environment can enable secure, efficient, and concurrent designs across all engineering teams. So within a digitally integrated and optimized multi-domain environment, all engineering teams, including IC packaging, FPGA, and PCB design within electronics, as well as mechanical and software, can optimize the cost associated with a project, accelerate design time, manage data integrity, and it can improve the quality of their designs. Breaking down the barriers between engineering teams and the disciplines, it enables concurrent design seamlessly within the electronics system into the overall product design flow. So that way, companies can get to market quicker with better product, and in turn, it drives increased productivity, it accelerates multidiscipline collaboration, and it improves visibility across multidisciplines and the teams, as well as it supports early visibility on control of cost, resources, and schedules, and definitely managing risks. So when we think about the best practice pillars, the first one I want to start off with is the electronic mechanical co-design. I can tell you from experience, if 3 decades of struggling of the handoff between electrical and mechanical, that is error prone in the legacy way of the way we've done things. The challenge that we typically meet is that the data is usually incomplete, or it has errors when you're handing off. And when we think about how we used to hand off, DXF files was one way, manual emails or a PDF drawing, or even worse, a handwritten drawing on a napkin. And those are the typical challenges that we're up against. Now when we talk about roadblocks that you may run into, and one of the biggest roadblocks is organizational resistance to change, and that's an indirect roadblock, but it is a big one, the resistance to change. Now we talk about siloed teams and siloed tools that just don't integrate well. Then you have unfamiliar formats in the data that you're handing off. And when we talk about best practices, the format that's the latest and greatest right now is the IDX format for the MCAD, ECAD collaboration. We should look for methodologies that enables context-based integral collaboration between the domains and the disciplines. Now, the value you're going to get from that is that you have streamlined, integrated collaboration that minimizes the risk of errors during the data exchange. Now let's take a look at an example of what I'm talking about.
An example of where digital integration is important is between electronic and mechanical domains. The handoff between MCAD and ECAD is critical, and it's vital that all the information that comes over from mechanical to electrical is accurate and correct. When we look at an optimized flow, the MCAD designer might start collaboration after adding data pertinent to the electronic designer to a design, such as board outline and critical component placement like connectors. Other critical features could be mounting holes, tooling holes, keep out zones and keep in zones, and any type of zones that may have specific height ceiling requirements. This information then needs to be passed to the electronic designer so that way it can be considered during the development of the PCB. As part of the process, certain items can be set to be owned by the mechanical designer, which means that these items can only be edited by the mechanical tool. Doing this helps eliminate any accidental changes to items critical to the mechanical aspects of the design that would cause any unnecessary rework downstream. Starting collaboration with the electronic designer is as easy as creating a baseline. With the baseline created, the electronic designer can look at the baseline and preview the information in the baseline file. This is why it's vital that the exchange between MCAD to ECAD to be as seamless as possible, and the data that's being passed over is accurate and correct. Items like the board outline, mounting holes, placement instructions, and components all show up in the tree view and allow the designer to make sure that nothing in the file would interfere with any work that may have already been done. Once the baseline is applied to the project, an assembly file can also be imported, which contains the mechanical models and NX assembly. Further changes in the domain can be set by creating proposals with either the domain experts having the ability to either accept or reject the proposed changes.
So another best practice to talk about is the design in manufacturing. And what I mean by design and manufacturing is the collaboration between design and manufacturing and how they're exchanging data. And it should be bidirectional. And in the past, what we've seen is the problems that we've seen and the challenges is that the data that we're addressing or the data that we're handing to manufacturing, it doesn't address producibility or manufacturability. And as we throw stuff over the fence, and I don't mean that literally, I just mean that the fact that you're handing poor quality data that it's not optimized, and you end up running into problems, which then leads to work stoppages because you have technical queries coming back at you to say we have an issue. And when we talk about roadblocks that feed into this is the competitive pressure from a fab shop or the manufacturing to accept the data and make internal changes on their end to tweak it just enough that way they can get it to move forward in their design with the fabrication. And they don't provide what they tweaked or what they adjusted back to engineering so that they will optimize and continuously improve as they produce their data. Instead, they're producing the same stuff, the same quality of stuff over and over, and this is what we're doing today in general. Now, when we talk about best practices, how we do this, or what we should be doing, is we should optimize the integration between design and manufacturing. How do we do this? We enable lessons learned from manufacturing, and we make sure that's fed back, or we're getting that feedback, that bidirectional loop, or that data exchange that influences the design, that enables that feedback loop. And by doing this, we utilize intelligent data formats, ODB++ and 2581. These type of data formats enable intelligent communication from engineering to manufacturing. When we talk about what are we going to gain from it and the value, we have an optimized integrated collaboration that minimizes errors during the data exchange, and it provides a continuous feedback loop of lessons learned. Now, let's look at an example of the design and manufacturing collaboration that we have.
The PCB stackup is the foundation to your PCB design, so it's important that you get it right. Detailed stackup planning early in the initial design process allows you to optimize your stackup by allowing users to perform pre-layout signal integrity simulations based on the actual materials your fabricators will use. This is why it's important that you get with your fabricator early on in the process. This allows for calculating single-ended and differential impedance, as well as insertion loss for microstrip signals, including the ability to add the effects of solder mask and hatch plane. After identifying the materials to be used in the design, you can use this information and start building the stackup using a wizard, which will walk you through the construction of the new stackup. Once complete, the stackup information can be exported and sent to the fabricator. There you can confirm to make sure that everything is exactly how you need and everything is built the way you want. A digital thread between design and manufacturing increases the potential for downstream success regarding the overall process. It enables teams to minimize the respins that often happen between design and manufacturing. Streamlining the transition to manufacturing requires sharing a complete understanding of the product and enabling early downstream access to the data. Running a manufacturability analysis before sending to your manufacturer allows users to catch issues before sending their design to their manufacturer, minimizing respins and eliminating the possibility of undesired changes made to the design by manufacturing. Potential manufacturing issues are easily identified and can be viewed within the tool. A report can also be exported for use in identifying problem areas that need to be addressed in the next revision of the data.
Another best practice of this pillar is library and data management. And what I mean by that is that how are you controlling your data, whether it's your library data or your actual IP. Now, I can tell you from experience after 30 years that companies are all over the spectrum. No one's consistent in how they do this. Now, that doesn't mean that they're not doing best practices, because everyone has their own way of what they call success, but there's ways to be better. And when we think about the typical problems you run into, is you would run into ineffective ways of how teams are collaborating or how you're sharing data or lack of sharing data. A lot of the roadblocks that we run into is that we have product, organizational, and process complexities, or you have too much overhead to maintain. That's always a big excuse. Or a lot of times you just don't have the experience on how to do that, or you don't have a specialist who knows how to do that within your company. Now, when we talk about best practices for this, is you want to establish internal guidelines. That way you have an internal set of guidelines and rules on how you're going to do things, So that way you're consistent from project to project to project. And it also gives you a way to look back to see how you can optimize and be better. You establish your industry standards and how you're absorbing them or how you're utilizing them. Because when we talk about different companies, or even nowadays in the global world, you may not speak the same language, but the common language is industry standards. Another way of doing this is your organization and control of your library and your data. You don't have it on a local server or someone's local desktop. Instead, you have it in a PLM system that'll help you optimize for revision control and where used, and it gives everyone better visibility of what's going on. So when we talk about what kind of value you're going to get from this, you'll get better control over your libraries, you'll get better use of best parts and best approved circuitry. You utilize hardware IP modules, you can control them better and implement them better. You have instant status, work in progress, and it also removes potential for errors and allows for visibility of where used and other type of information that you may need to know during the work in progress. So now let's take a look at an example of library and data management.
Library and data management throughout the design process is essential to maintaining a digital thread throughout the lifecycle of a product. I've heard of and witnessed firsthand how poor library and data management can be extremely costly, lead to schedule runs, and in a few instances where it became catastrophic. So believe me when I say library and data management is extremely important. Once development is begun, data management is essential for maintaining design information such as design revisions and enabling team collaboration no matter where team members are located. With today's design and manufacturing team members globally located, access to data and the integrity of the data is very important. The building blocks of any design are contained in the library used to create it. Having a tightly integrated and optimized library environment enables designers to keep track of everything, from 3D models to component data sheets, as well as suitable alternates. It speeds up part identification, selection, usage, and makes it quick and easy to search and instantiate a component into a design. Once a design has reached a milestone, it is time to release the design to a PLM system like Teamcenter. This could be done to simply send the bill of materials to a PLM system for analysis, or it can be full release that contains all of the manufacturing outputs.
Thanks for tuning in, and I hope you continue to follow along. Next time, we'll cover PCB best practices that enable engineering productivity and efficiency.